Assalamualaikum and good day to everyone watching. Today, our group MEC19 would like to explain a little bit about our FYP project, which is EG tile, or as we call it, electric generator tile. So, me, Muhammad Izan Ilyas, with the matrix number of AA230060 as our group leader, we would like to give you a little about our introduction. So, electric generation tile, or we call it EG tile, convert the kinetic energy from footsteps into electrical energy when the pressure is applied. This sustainable technology captures and stores the energy to power low consumption devices like LED lights, digital display, and mobile charging stations. By installing these tiles in high traffic areas such as airport, train station, and shopping malls, they can take advantage of constant foot traffic to provide an eco-friendly power source.
Our research background is to develop an innovative electric generator tile using a crank and slotted lever mechanism instead of piezoelectric materials. As people walk on these tiles, their foot pressures activates the lever system, converting kinetic energy into electrical energy. Unlike traditional piezoelectric flooring, which is costly and face efficiency and durability challenge, this alternative design offers a simpler, more affordable solution by utilizing physical displacement. By implementing these tiles in high traffic areas, such as malls and schools, we can provide a sustainable and cost-effective energy sources. If successful, this project could reduce dependence on fossil fuels, lower manufacturing and maintenance costs, and create new opportunities for energy generation in everyday environments, contributing to a greener future. Our problem statement is, with the limited supply and environmental impact of traditional energy sources, the need for sustainable alternatives is becoming increasingly important. Electric generation tiles offer a promising solution by converting the kinetic energy of footstep into electrical energy. However, several challenges must be addressed, including energy conversion efficiency, durability, affordability, and integration with existing power system. Public awareness and acceptance are also crucial for the widespread adoption of this technology. Optimizing the design and implementation of these tiles can help maximize energy output, reduce costs, and promote their use in both public and private space. Our objective is to develop a functional and efficient EGTIL systems. Number 2, to evaluate the optimum design mechanism for EGTILs. And lastly, to determine the power harvest by EGTIL. Our project scope is focusing on developing an innovative EGTIL system that converts kinetic energy from footsteps into electrical energy. The design includes a functional prototype capable of generating 12-volt DC electricity, featuring a stepping plate decorated with mosaic elements as the user interface. To enhance the durability and efficiency, a customized 3D printed mechanism is incorporated. The generated energy will be used to power a 12-volt LED and store in high-capacity 18650L ion battery for future use, providing a sustainable and efficient energy storage solution. The EGTIL system is expected to significantly reduce the carbon footprints of facilities by harnessing renewable energy from kinetic motion. This adaptable solution can be installed in various locations, especially in high foot traffic areas. By capturing energy from everyday activities, the EGTIL system promotes a more sustainable and eco-friendly approach to energy consumption.
So, the component that exists in our project, including dynamo, crank and slot mechanism, gear, spring, bearing, and also electric circuit. So, what is a dynamo? A dynamo is a device that converts the mechanical energy into electrical energy. In the EGTIL system that we use, the dynamo is powered by the motion of the crank and slot mechanism, which is rotated into internal components. The rotation creates a changing magnetic field that induces an electrical current in the dynamo's coil, producing the alternating current. The dynamo acts as the primary source of electricity for the system. Our group has decided, instead of piezo, we decide to use the crank and slot mechanism. The crank mechanism are essential in many mechanical systems by converting the rotary motion into linear motion or vice versa, and are widely used in various industries. Basic crank mechanisms are found in engines and manual devices, while slider crank mechanisms are used in piston engines and pumps for efficient energy transfer. Bell crank mechanism, with two arms positioned at a right angle, alter motion direction in aircraft control. The Scotch yoke mechanism provides smooth suicidal movement, ideal for internal combustion and in steam engines. Offset crank mechanism offer variable screw length for adjustable machinery, and the crank and slotted lever mechanism is used in sawmills and cutting machine for precise motion control. The wobble plate mechanism efficiently converts motion in axial piston pump and compressor. This diverse mechanism highlight the importance and versatility of crank system in modern technology, with the crank and slotted lever mechanism being the most suitable for our project. So, what about gear? Gears are used to transfer motion and torque between parts of a machine. They have teeth that mesh with other gears to transmit rotary motion. Gears can change speed, increase or decrease the torque, change the direction of movement, and help transmit the power. Different types of gears such as spur, helical, bevel, and worm gears are used for specific tasks, making them essential in machines like car, clocks, and engines. Spring. A spring stores and releases energy when it is compressed, stretched, or twisted. Its main functions are to store energy, absorb shocks, regulate force, and return parts to their original position. Springs are used in many things like machineries, vehicles, and household items. The most important part of our component is also a bearing. A bearing reduces the friction between the moving parts, making movement smoother. It supports weight, helps distribute loads, and allow the parts to rotate or move easily. Bearings are used in many machines like motors, wheels, and fans. And the last one will be electric components. So we decided to use some of the electric components that mainly function well in our project, which is the voltage regulator, full bridge rectifier, capacitor, protection board, and also the rechargeable battery.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zikri Faiz bin Mahmud Fauzi. My matric number is AA231810. Today I will present design stage and mechanism design. So what is design stage? Design stage is the stage that our foundational blueprint for the project. This stage is incorporating initial concept and consideration based on identified requirement and constraints. This stage focus on problem solving and creative exploration. This stage help us to identify areas for improvement and ensure that our preliminary design is optimized on the end of our final product. In total, we have 3 designs, and this is our first design that suggested by me. I suggest to use right and pinion mechanism, which is this mechanism will convert linear motion to rotational motion. This rotational motion will convert into electricity by using a dynamo. In this design, I also include LED strips that will indicate that our product is producing power. This is our second design that suggested by Izwan. Izwan suggests to use a single spring mechanism that's connect with a bevel gear system that will turn the dynamo in and produce electricity. This is our third design. This design using a rectangle design and 4 spring mechanism. The tile on top of it is connected to multiple bevel gear mechanism. This multiple bevel gear boosts rotational speed and energy output for the best performance. So this is our final design. This design use 4 springs that connect to our mosaic on top. This design able to show our mechanism to our audience. This is our detailed design that include our mechanism on it, and there are list of our part. This is ortho and ISO drawing for our product. We can see here we using crank and slot mechanism, using 3 set of bevel gear and 2 set of spur gear. This is exploded view drawing that have numbering parts on it. Next, mechanism design. So in this project, we have changed our mechanism design 3 times. So this is our first design. We are using only bevel gear in the normal position. In this design, we found out that this design take a lot of space in terms of long and height. So this is our second design. We use bevel gear, but this time we change the position. So we change the horizontal bevel gear position. First we put it at bottom, and then for the second set we put it on top. So we repeat this position until the end of our bevel gear. We found this design have solved the high problem, but this product is considerably long. So we need to solve this long problem. So this is the third and last design for our mechanism. We only use bevel gear and spur gear. For the bevel gear position, we put the horizontal bevel gear at the top, and the small vertical bevel gear is connected to a shaft that have a spur gear on it. We only use 3 set of bevel gear and 2 set of spur gear. In this design, we have solved the problem which is we have cut the height and the long of the product. This is our animation of our product. So we can see right here, when the tile holder is pushed down, the spring is compressed, and at the same time our bevel gear is rotating. This is our animation of our product. So we can see right here, when the tile holder is pushed down, the spring is compressed, and at the same time our bevel gear is rotating. This is our animation.
So we arrive in the conclusion. The electric generator tile project demonstrates the potential of harnessing kinetic energy from foot traffic as a sustainable energy solution. By using a crack and slab mechanism instead of traditional piezoelectric materials, the project effectively addresses cost, durability and efficiency challenges. Through careful material selection and iterative improvement, the design is optimized to generate and store electrical energy for low power applications such as LED lighting. The successful implementation of EG tiles in high foot traffic areas like schools and malls can contribute greatly to renewable energy efforts and help reduce carbon footprints. Future improvement could enhance the energy conversion efficiency, optimizing the design for mass production, and maybe explore a better way for the energy storage option, making the EG tile a promising step towards sustainable infrastructure. That's all from our group, and thank you. Have a good day.